Good evening or good afternoon, depending on where you're tuning in from. Welcome to A Day in the Life of a Scientist panel discussion. My name is Michael, and I'm a third-year PhD student at Johns Hopkins pursuing a doctorate degree in biochemistry. Don't worry, if those words don't mean anything to you, that means you're in the right place. I'm here representing Black Scientists Matter, and I will be moderating today's event. This event was born from a conversation that I had with representatives from Berkeley Extension many months ago about systemic racism in America and things we could do to impact the next generation of students through representation and exposure. We next roped in Black Girls Code to begin planning this event. The goal of A Day in the Life of a Scientist is to introduce younger students to potential careers in science by demystifying what a scientist is and what a scientist does. And now I'm going to pass it off to Leonard from Black Girls Code.
Hey everybody, my name is Leonard. I'm the virtual program manager at BGC. We are so excited for you to join us this evening. We hope you leave this event inspired, and we really sincerely appreciate you joining us. And now I'll pass it back to Michael to introduce our amazing panelists.
So this panel features 5 women from different backgrounds who will be sharing their experiences as scientists and providing career guidance for you all. Throughout this event, feel free to submit your own questions to the panelists as well. Now it is time to introduce our speakers. For my panelists, after I read your bio, please wave and say hello to our audience. First up, we have Tiara Lacey. Tiara, is a third-year PhD student in the Biological and Biomedical Sciences program at Harvard Medical School in the Neurobiology department. She studies the development of brain cells related to anxiety, aggression, and memory-related behaviors. Next up, we have Jasmine. Jasmine is a PhD student at Johns Hopkins School of Medicine. Before enrolling at Johns Hopkins, Jasmine graduated from Hampton University with a degree in biochemistry and participated in the NIH Post-Baccalaureate Prep Program in Seattle, Washington. Jasmine enjoys indoor gardening, cooking, and volunteering with Baltimore City students in the sciences and arts. Glad to have you, Jasmine. Next up, we have Marilyn Berrigan. Marilyn Berrigan is a first-generation college student born in Los Angeles and raised in Kansas. She's currently a first-year MD PhD student at the University of Illinois at Chicago. She's going to explain more about what an MD PhD is for us later. She graduated from the University of Kansas in 2018, where she majored in molecular, cellular, and developmental biology. And she's been involved in research ranging from bioengineering to public health. Outside of research and studying, she enjoys reading, running, and going out to dance with her friends. How you doing, Marilyn? Next up, we have Chia Maka. Chia Maka is a third-year PhD candidate in the Department of Pharmacology at the University of Michigan, where she studies heart disease. An alumna of the Fulbright program, she completed a 1-year research project in Belgium, investigating mechanisms of antibiotic resistance, while also advocating for Black scholars in the program. Outside of the lab, you'll find her dancing anywhere she can and performing poetry. We have Sierra Hasinin. Sierra is a member of the Crow Creek Sioux tribe with her maternal family originating from South Dakota. Sierra graduated from Johns Hopkins University with a bachelor's degree in neuroscience. Following graduation, Sierra was an NIH-funded prep scholar at the Johns Hopkins School of Medicine, where her research focused on spinal muscular atrophy. Later, she joined the molecular and cellular biology program at the University of Washington in 2019, where she studies the relationship between brain cell location and bodily movement. How you doing, Sierra? All right. So first off, I want to say thank you so much for our panelists for being here today. I'm glad to have you guys. I appreciate you for your time, sharing your opinions and your experiences as women in science. Without further ado, the first question for our panelist is, what is a PhD?
Okay, so a PhD, it's a doctorate of philosophy. That would be the first answer.
Okay, it is. So I guess a follow-up question for you, Tiara. What is a PhD? Specifically, what makes a PhD different from a bachelor's degree or master's degree or any other level of education?
Gotcha. Okay, well, a PhD is something we call a terminal degree. So that means that's as high as you can go. There's no degree that further after a PhD. Yeah, and this is a research degree as well. So there's like a original research component to it as well. So that's something else that gives it the philosophy component, because usually you're studying something, you then compose this body of original work, and then you present it or publish it.
Thank you. So could anybody expound a little bit upon the idea of research, what exactly it means to do research in a PhD program?
I can hop in here. I would say research and a PhD in general is the process to create knowledge. So you're really asking questions. You are doing qualitative and quantitative research. So doing research that's descriptive, like describing a situation or a phenomenon that you see, or you're counting things to describe something that you are seeing in the world. And you're really like stringing together all of your findings to offer something new to the world, something like a fact that the world hasn't seen before.
Okay. So one part of the PhD is that you have to conduct novel research or generate new knowledge. I think that's definitely one major difference between a PhD and any other type of degree. Typically, for our audience, you usually, you go to school and you learn the information that's presented to you. The difference between a PhD student and a regular student is that a PhD student is tasked with generating new knowledge, as Jasmine said. So at the edge of the things that we know, that's where a PhD starts. And the idea is to make a discovery or contribute something new to your field of interest. All of our panelists are scientists, and they're specifically getting their PhDs in different fields. So next question that I wanted to ask is, why did you ladies decide to become scientists?
I can start with this question. I think it kind of flows in from the previous question that you asked. So when I was in college, I majored in biochemistry, and a lot of the things I was learning was about how our bodies work. I learned about what happens when our bodies function properly. And then what I found really interesting was what happens when things go wrong in the body. You know, if you get sick, how does your body respond to that? Why do you get sick in the first place? Why do some people recover from certain diseases or illnesses? Why don't other people? And so when I finished college, I knew that I wanted to do more. I wanted to take that knowledge and apply it in a way where I could help people who were suffering from disease. And so that's really where the PhD comes in. As the other panelists mentioned, you produce new knowledge. So if we know how the body works and we know what goes awry, how can we piece, together that information and then discover something new that we can use to then either treat disease or help other people. So for me, the driving factor in going to grad school at all, but specifically getting a PhD, was I wanted to apply that knowledge and also kind of use my creative part of me to say, okay, how can I solve some of these global problems that are impacting humanity? So it was a merger of the things I was interested in. I just think science in the body is cool. I think understanding how our bodies function is really interesting, but also the piece of what can I do to help others and help society. So that's what really pushed me to start my program. And so one of the things I'm working on is heart disease. So when our hearts are, not functioning properly, I'm literally in the lab working with heart cells pretty much to study, okay, this is what happens when it goes awry. What can I do or add to these cells to get them to start beating normally? And then how can we translate what I do in the lab into people who actually have these types of heart disease? So I think it's really interesting and really fascinating, and is why I love being a scientist and why I love getting the degree that I'm getting now.
Thank you. That was a great answer. Would anybody else like to chime in on why they decided to become a scientist?
I can add to that. Hi, everyone. So in high school, my grandfather was diagnosed with Alzheimer's, and that's when I became interested in neuroscience and it was a very debilitating disease, and I saw him daily at the memory care home, and I started to want to understand what is the underlying biology of this awful disease. And so that's what I majored in college. And then further off of that, I know some of our communities, and me specifically in the Native community, a lot of my family members sadly have high morbidity rates in terms of having diabetes, heart issues. And so this is something that was personal that I saw like firsthand, and I wanted to, you know, have an impact on that by doing research, which, you know, research can make a huge impact on the world. Whereas like, you know, it's great to be like an MD doctor where you're helping people one-on-one, but research has the opportunity to like find new therapies for multiple people and help us understand like what is the underlying factors, genetic factors, as well as like, we know a lot of our communities have different environmental factors that might be at play. So all of these things are reasons why I also became interested in research. Thank you.
I think you touched on a great point, which is really the difference between a medical doctor and a PhD. So, you know, medical doctors see patients and they diagnose diseases, but PhDs are really the ones doing the research to find the cures and the treatments. And so definitely less patient contact, but maybe more broadly applicable depending on how you think about it. So I appreciate both of you guys' inputs, Sierra and Chia Maka. Could one of our panelists give us the brief outline or the structure of what a PhD looks like?
I think we'd be remiss without having Marilyn chime in on this MD PhD chat right here.
Yeah, I would love to chime in actually, since you mentioned, Michael, the difference between a doctor and sort of like a PhD doctor. I'm completing an MD PhD, which is both a medical degree to become a doctor who sees patients, and then a PhD doctor who actually learns how to conduct research, which is what all the other panelists are doing, to kind of become experts and contribute to the scientific knowledge that a lot of the times doctors use in order to come up with a treatment plan for their patients. And so I'm doing both, and it's a lot, but I think it'll be very rewarding because not only will I have my own patients that I get to see and learn from and see how they're how the disease manifests in their own life, but I also get to think about what are like the critical points that we should be studying and better understanding through research. And so that's kind of my career goals. And I think I decided to become an MD PhD because I really didn't want to just choose to be a doctor who just saw patients and a scientist who worked on the discoveries. I really wanted to be a doctor who worked on discoveries related to sort of what I saw as a doctor. So yeah, it's a little bit about why I went into an MD PhD program, which I can talk more about later.
Thank you. We would gladly hear more. I guess TR, could you answer the question that I was asking about the structure of a PhD? So when you decided to go to grad school, you know, you wanted to study biology because you're interested in learning more about treating diseases or doing research. Once you get to grad school, what does it take to finish or to get a PhD?
Tenacity. That's what it takes. Honestly, I think anything you do in life that's worthwhile is going to take a lot of, so it just this will to like not give up. So that's tenacity, just every day, because it's hard. I mean, going to school is hard at any level. When you're challenging yourself to learn new things, it's hard and it's difficult. And especially where we're at, like I know Michael touched upon it, like undergrad, you're like learning things that people have already discovered, and then in your master's you're kind of on this kind of I would say like no man's land of like learning new things learning things that people have already discovered and trying to create new knowledge. But then with PhD, depending on what type of program you do, you're playing catch up with things that people have already found, and then while simultaneously trying to create new knowledge. And so it's just this balancing act there, but more of like the structure. So do you mean like first year through like graduation, or do you mean like in a typical day?
First year to graduation.
Okay. So first year.
Question, sorry to cut you off. First question is, how long does it take?
I would say it depends on your program. So see, like my program, like that, they don't ever like, that's the one thing I miss about like undergrad or like more structured programs, is that they'll say, okay, you're gonna be done in like 2 years, or you're gonna be done in like 4 years. But like a PhD is different, it's self-paced. And so it's kind of whenever you finish. And I'm like, no. And so like for my program, like the average time that people typically finish is about like, if they said like 5.6 years, so like rounded up 6 years. But yeah, that's for, I'm doing a biological sciences PhD, but I mean, depending on if you're doing like a computer science PhD, it could be like 4 to 3 years, or you know, if you're doing like what is it, just a real hardcore neuroscience one, you could be doing 8, 7, 8. Just depends on where you're at.
Perfect. Thank you. So Tiara told us a little bit about how long it takes. Could anybody tell us a little bit more about like the actual process?
I'll jump in on that. So the process, once you're already in graduate school, for about the first year to the first 2 years, you'll be taking classes, getting to know your cohort, rotating in different labs so that you can try out different subjects and get your feet wet and figure out what you like. And then around year 2 to 3, you'll choose a lab, you'll start reviewing all the things that you learned in the first 2 years, and you'll take an exam, sometimes called a qualifying exam. And it's not a written exam for most people. You usually get up in front of a panel of your mentors, other scientists, and you kind of explain what you know. And you also come up with other ideas on the spot. So most people pass that exam just as an exercise to think on your feet and be creative. And then after that exam, you move forward and you work in your lab, you start asking questions about your research, and you start to collect data, and then eventually you'll start writing a dissertation. Once you're at the dissertation point, you're almost done, and that's really a PhD in a nutshell.
Thank you. That was an amazing description. So you mentioned part of a PhD is actually doing research and going into the lab. But our audience, I don't think they are really familiar with what research is or what it looks like. So could one of our panelists tell us a little bit more about the day-to-day activities of being a scientist?
I can start. So I can speak specifically to what I do in the lab. So I mentioned I'm basically studying heart disease. So I'm looking at how our hearts beat. So for those in the audience, if you put your hand on your chest or maybe 2 fingers around your neck, you'll feel a pulse. You'll feel your actual heart beating. And so what we do in the lab is study what are basically proteins, which are, you can call them entities in your body that are responsible for regulating that heartbeat. So if you get excited, your heart will beat a little bit more faster. Maybe when you're asleep, it's a little more calm. So we're studying the patterns of your heartbeat and how we can monitor that. So in the lab, for example, this week, I'm going to go into our research facility, and we have cells that are basically mimic human heart cells. So they're not actually cells from humans, but they're cells that mimic what our heart cells do. And then I'm going in the lab with these cells and basically studying how they work. So what regulates them, what changes that rhythm that you feel in your heartbeat, what happens when things go awry, and how can we fix them? And so I'll take a dish of cells, look at them under our microscope. So that allows us to kind of just laser focus in onto these cells and see how they're behaving. And one of the things I really like about the project is we have different types of compounds or drugs, essentially, that we're trying to turn into medication. So to treat specific types of disease. So I'll first monitor these heart cells, heart-like cells, and then I'll add these drugs, and then I see, okay, how does that change the rhythm? Does it make them beat faster? Does it make them beat slower? Does it beat in the way that I predict it's going to be? And if yes, then what's the next step? So I would say generally the day-to-day is just kind of like asking small questions and trying to come up with the answers so then you can build kind of a bigger story. The long-term goal would ultimately be to finish the project with a new therapy in hand, something that we could literally give to people that have a certain type of heart disease. But there are a lot of checkpoints along the way to make sure that these drugs that we're working with in the lab, these potential medications aren't going to harm people. So there are a lot of things that we need to test to make sure. So you could kind of think of it, I would give the analogy, if anyone likes to cook or likes baking, it's like, you know, each step of the way you're tasting to make sure, okay, this tastes the way that I expect it to, I can move on to the next step. I can add the next ingredient. And then the final product is what you want, maybe a 10-course meal or a really nice cake. So it's kind of adding little bits and pieces to the story until you're sure as can be, that you have the final product that you want. So that's kind of my day-to-day in the lab.
Thank you. Would anybody else like to chime in?
I really like the baking analogy because when I think about my day-to-day in the lab, if I was baking, I would need like a mixer or a whisk or a spatula, an oven. And so when I go to the lab, I'm using certain instruments in that same type of way. So there are special machines that I think all of us might use depending on what we're interested in. And so we kind of read to figure out what step we're at. We taste a couple things and then we go to our instruments. And so I think that's I think that's a good description of what our day-to-day is like in the lab.
I think there are a lot of parallels between baking and doing science as well. Can we get one more person to chime in on what their day-to-day is like as a scientist, and then we can move on?
I guess I can go. I bike to work, I get in the lab, and so I work with worms. And so I know a lot of researchers work with a type of animal model in a very safe way. But what I work with is really small, and essentially I check on them, and I do that by looking at them under a microscope, and kind of I can take notes on, you know, if they look different, on their behavior. And then also something I can do is like change the genetics of these worms through what's called like a mutation. So you mutate the worms, and you can also do this in like other animal models, and then also see how that changes. So I work with a lot of microscopes. I do behavior assays, so essentially just looking at how they behave. And then I also talk a lot to people in my lab. Like, thankfully, I'm in a lab where I enjoy it. I made sure to pick a lab where I like everyone that's in the lab and I feel comfortable with. So they're my friends, and I meet with my boss, who is called a principal investigator. And I'll sit down with him and talk about my project and what I need to do to stay on track to, you know, keep doing my experiments, to, you know, what I need to do in order to be a scientist. And he's sort of like one of my many mentors, which is another thing. Like, I would advise that through grad school, I found a lot of mentors along the way. And then a lot of sitting at my computer, like looking at data and putting them in like pretty figures. And that's when you can be a little bit creative sometimes too. Yeah.
Thank you. So I guess for our audience, who are all, you know, younger students, graduate school seems kind of far off because, you know, they haven't yet gone to college, and then what comes after that. So I was wondering from our panelists, could you tell us, it's a two-part question. First of all, why go to grad school? And after college, of course. And then the second part is, what does it take to get into grad school?
Okay, yeah. So for me, I really wanted to go to graduate school because I felt like it was going to open more doors for me to get to the next level of what I ultimately wanted to do, which is to be a physician scientist. So in order to be a physician, you absolutely have to go to medical school. Like, you have to get board certified and all of that. But also in terms of the PhD, in order to be able to ask novel questions and gather new information in your field, you have to be an expert. And in order to do that and to be qualified to do that, you really have to have the PhD training. And so, yeah, it seemed natural that the next step was to get a PhD, just to have those doors open and be able to do the work that I wanted to do.
Good answer.
I felt the exact same way. I was in high school and I was looking around at what I can do, what my options were. And I felt like getting the highest degree I can get, a PhD, was the best way to have more options to choose what I want to do. Um, I feel like, Michael, your question was, how do you get there?
Yep.
So when I was in high school, I was looking around at what classes I really enjoyed. I really enjoyed chemistry. I like to volunteer and like build things with engineering clubs. I thought that was kind of fun. And then when I got to college, I talked to my science professors. I just kind of like told them that science was cool to me, and they guided me to different summer programs where I can test out whether I liked being a scientist. And I think that was the best way for me to get on the path to a PhD, because during college, I got to spend those summers like in different cities, places that I'm not from, and meet new people and try new techniques and learn new areas of science. And that is really the best way to get into a PhD program, to like explore and have experience in science.
Gotcha. Okay, thank you so much. So one of the main factors when trying to pursue a PhD is research experience. So one of the questions that I think our audience is wondering is, what jobs can you do with a PhD in the biological sciences?
I can go. Well, I don't know if our audience knows, but I also wanted to note that you get paid to go to graduate school. So that makes it a little bit more accessible to some of us. So if you really like learning, like, why not get paid while doing it? But after graduate school, there's lots of options. A lot of people are interested in going into like staying in what's called academia, and academia just means like college institutions. So you do research, you essentially would work your way up to conduct like your own lab and have your own lab and do your own research and have your own team. Also, some people, you can teach like college students while doing this, or some people go directly into straight up like just teaching if they really like teaching people and mentoring others. And so different universities are more focused on research versus more focused on teaching. A lot of people go into something called industry, where it's known to pay more, but you know, you can think of like in COVID times, these people that are like working for the pharmaceutical companies and doing that research, that would be considered industry. But there's a whole bunch of industry options, and you know, that we have. And then some people work for like the government and do policy work, you know, if you wanted to make science more accessible to our communities, or work with the government to, you know, after 5 years or however many years, you have all this knowledge on how science works and how the game works. You're able to help people in the government, you know, make that accessible to everyone else. I'm sure I'm missing others, but those are a few things you can do after you go to grad school.
Thank you so much. I think among the jobs that you listed, one of the common themes is that there's actually a lot of flexibility in getting a PhD. And so if you get a PhD and you really, really love being a scientist at the bench, doing experiments and conducting research, you can keep doing that for your entire career. But the skills that you learn and the knowledge that you gain from a PhD can also broadly apply to a number of different fields as well. As Sierra mentioned, there's industry where you're working at like a pharmaceutical company. There's also patent law where you're combining science and law. There's also policy, which she mentioned, which is advising the government on issues that pertain to science. One example would be like climate change. There's also nonprofit research you could do. But there's a number of different opportunities that getting a PhD can afford you. So I think that's one thing that really sets a PhD apart from other degrees, is the flexibility of what you do after that is really up to you. So the next question that I wanted to ask is, what is your favorite part about being a scientist, and what is the most challenging part about being a scientist?
I love solving new problems, and I love knowing that when I come into the lab, I'm the only person that thinks the way that I do. So it's nice to feel like, I'm making a unique contribution to the field that I'm in. So I think one of the things that I really wanted was, I wanted to answer different questions every day, and I didn't want to feel like I was doing the same thing over and over and over. So it's nice to know that there's always going to be a problem that needs to be solved, and there's something that I can do to help with that. I would say one of the most challenging things about the program is kind of also related to what it takes to get into grad school, but I would say failure and learning to be comfortable with that and move past it. So I would say part of the reason PhDs vary in time is it depends on how hard you fail and how quickly you get back up and answer those questions that you need to figure out. But it is learning how to persevere, being comfortable with not knowing the answers to things and picking yourself up and affirming yourself and your worth when things don't go the way that you want. And I think that's just a valuable life skill to have no matter what you do. And related to that, I think that's also part of kind of getting into the program. They can be relatively hard to get into, but I'm a firm believer if it's something you're passionate about and that you love, where there's a will, there is a way, and there are people who are willing to help you. So yeah, I would say kind of learning to overcome your challenges with grace and still from a good place.
I would echo those same sentiments. Tiara, did you want to?
Yeah, I think everything was pretty much covered. Yeah, I just like the favorite part is like learning new things, and then I would say the hardest part is to, just failing with grace over and over every day. Yeah, I think that that's definitely a hard part, but then also like it goes back into like the whole having this will to like persevere. And I think that that's like anything, it's a muscle. It like you start off kind of weak and you're like, oh no, they said they didn't like my presentation, and then eventually it's like, oh, ha ha ha, ha. They didn't like my presentation, let's go edit it and make it so that it's less awful. So yeah, I think that it's I see a couple of somebody laughing because yeah, it resonates. Yeah, grad school's hard, but I mean, I think that's also the same thing with any level. I think that that's starting young. I mean, just dealing with failure and like learning to deal with failure. That's like a great skill to have going into grad school. Because if this is the first time that you have failed, or the first time you've been told no, let me tell you, baby. Jasmine, you look, you got something to say.
I was just like, baby girl, this is not it. This is not the only time. But no, I definitely can relate to that. I would say that the best part about graduate school is seeing yourself grow. So just like the presentation example, like your presentation can be awful the first time, but soon you'll be killing it. And I think that is the most fun. And that makes it the hard part too, is just really kind of locking in and being dedicated to growing. That can be difficult sometimes. Yeah.
So you guys all touched upon a common theme, which is perseverance. But for those who aren't familiar with conducting scientific research, why is failure such an integral part of the process?
I don't know. I think of like the Thomas. Is it Thomas Edison, y'all? The Tom with the light bulb, where he was like he failed like 1,000 times, and then like the 1,001st time he got the light bulb to work. And so I think it's just like failure needs to happen because to rule out things that don't work. And if you get things right on the first time, you really don't learn very much from that. Yeah, I mean, even though it's like it's nice, like, oh, this is a W, but it's like, do you truly know why this is a W? Not at all. You're just going with the flow.
And on top of that, if there was no such thing as failure in grad school, we would have discovered everything by now. So we have to fail and like figure out how to improve upon those mistakes so that we can like discover things. So yeah.
Exactly. I feel like if it's new, we're supposed to be doing something new. We're supposed to be creating new things. And when things are new, you don't get them right the first time.
I think these are all great points. I think one easy example is like with the COVID-19 pandemic going on. If scientists had all the answers on day one, we would all be able to go back outside without masks on. But we can see that when you are asking very difficult questions, scientifically, it takes a lot of time, it takes a lot of trial and error to get the right answers. So I think that's really a part of the process of being a scientist. When you're asking those hard questions is to persevere, because you're going to get way more no's than you will yeses when you're conducting research. So the next question I would like to ask our panelists is, what piece of advice would you give to a younger student who's interested in a career in science?
I can answer this one. So I actually started getting interested in science my senior year of high school. And I remember that I didn't really know where to start because it's very daunting when you first are kind of interested, kind of like, how do I even join a lab? Like, what does that step look like? And I think one of the things that I would advise is to be very comfortable asking for help, because none of us know everything. And a lot of people are really willing to help you get started and to help you develop yourself and your interests. So I would definitely say to, not be afraid to ask for help and to ask as many questions as possible, just so that you can kind of better understand what it is that you're interested in, what sorts of things excite you, and also like who you can have on your bench to help you get to where you're trying to get to. So yeah, those are some advice that I would definitely give.
To add to that, I think I've been looking at some of the questions in the chat asking about like, what challenges or barriers did you face getting into the program? I would say, in addition to if you know you have an interest in science or you're thinking about it, right? Like as is mentioned, seek mentors, talk to people, get help. I think what's exactly in line with that is also like not taking no for an answer. Sometimes you will reach out to people to mentor you or try and support you, and sometimes they will not be in your corner. They won't be on your team, they won't be on your side, and they may say things that are not encouraging or uplifting to you. And I think it's important to find people like relentlessly, like do not give up until you find someone that whatever feedback they give you is coming from a place of kindness and from a place of love, right? There are ways where someone can tell you like, hey, you can do a better job from a nice, perspective or in a mean way. So I think it's important, like Marilyn mentioned, to ask for help and kind of see what opportunities are out there. Talk to your teachers, talk to your friends, your parents, colleagues, us. Social media, if you see scientists, a lot of us are willing to, reach out and mentor and help. But just, I think stick with it if it's something that you are excited about, because you will find people that genuinely care and want to help you.
Would anybody else like to chime in?
If I can just share a story real quick. I know the first time I was starting to join a lab, I was really interested in bioengineering, like 3D printing of like tissues and organs. And when I presented this idea I wanted to do like a science fair project as a senior in high school. When I presented the idea, my science teacher discouraged me from pursuing that. And she told me that I should be, I believe the words she used were like more realistic about what I wanted to do. And so I think it's important to know that sometimes you might be discouraged from doing what you want to do. But it's important to kind of take those words with a grain of salt and find a way to make it work for you if it's something that you're really interested in. Because I ended up reaching out to a professor at the University of Kansas, which is where I went to school, and he was willing to help me as a senior in high school. So sometimes you gotta not take no for an answer and do what you gotta do.
Thank you so much for that story. So I think we've touched upon some similar themes from that last question. So at this point, we're taking questions from the audience. If you guys have questions for our panelists, please feel free to drop them in the Q&A. The first one is, what are the challenges of grad school, specifically being a woman of color?
Woo, Chile. Just gonna laugh it out. You know, laughter is therapy. Well, whew. I think it is, the first thing that comes to mind is not seeing yourself reflected enough in these spaces. That can be very hard. Depending on the environment you're in, which is why I think at any stage, it's just really important when you're choosing a school or a job or a grad program that you find spaces where even if you don't see yourself reflected, like people care about bringing more people like you into these spaces. People care about making you feel comfortable and feeling supported and welcomed. For me, it's been challenging. My year, I think we had maybe 9 students who started the program, and I was the only Black person. And that has kind of been my experience in a lot of science spaces. And it's just hard because sometimes you just feel like you don't have people around you that relate to you. Sometimes you suffer from imposter syndrome, which is basically feeling like even though you've put in the work and you've worked really hard to get to where you are, you still feel like a fraud, even though, it's baseless. There's no reason why you should think that about yourself, but it's just like those feelings come up. That has been particularly hard for me. I'm a Jersey native. I love being in cities where there's a lot of diversity. So people from different cultures, background, race, countries, so I love to meet people from all over. And coming to school where I am, it is not that. And it's hard. And one of the ways that I try to navigate that is building my own communities here. So there are other Black women scientists here that I connect with. We meet with each other. We talk about our struggles. We're kind of like just a little family here. And then I intentionally go out of my way to get out of campus, and whether that's traveling to Atlanta where I went to undergrad, or going back home to New Jersey, or a quick trip to Detroit or Chicago, which is driving distance, I make sure that I am proactively feeding myself socially as well as academically. But I would say there's many, but the first one that comes to mind is just kind of like it's sometimes exhausting feeling like the only one. And it's catch-22, because in the same breath, it's like, well, if I'm the only one here, then I belong here. Like I'm making a difference, and somebody else will now come and see me here and at least have that one person or that one resource. So I try to, look at the silver lining, but it is definitely challenging.
Yeah, I definitely feel that. Yeah, and definitely with the imposter experience. And I say experience really intentionally because that's different than imposter syndrome, where it's like with the syndrome, the onus is on that individual versus like the experience is like the system that was created to make you feel crazy. And it's like, it's just gaslighting you. Oh, okay. So sorry, children. Gaslighting. So that is basically when someone when someone tries to make you feel as if you are wrong for feeling the way that you are, even when you are right. And so that's gaslighting. And so so that's just a big experience with like women, and particularly women of color in science. And so you'll have people to try to limit you or put you in a box, and that's just them. Okay, I want to say projection, but I know that you guys okay, basically because they can't do it, they are going to assume that you can do it. And you guys got to just ignore that and keep moving forward and just believe in yourself, in your abilities, definitely. And just keep on moving forward. And like people will really say anything to you. Like, what was it for college? Someone said that I got into college from affirmative action, and I went to Spelman College. That is all Black women's college. So that is just one anecdote of people will really talk out the side of their neck to you, but do not let them get into your mental headspace. Just block out the haters and just keep doing you, because I can definitely, I feel like I can speak for all the panelists when we say we believe in you and you can do it.
I definitely think that the panelists here in front of you guys are evidence that it's possible. So the next question from our audience is, I think we're gonna go a little bit, I like this one. So Bree would like to know, what is a biological scientist? So I think we kind of talked about it broadly, but we never really specifically defined it. So can one of my panelists tell Bree what a biological scientist is?
Biology is the study of things that are alive. So biological scientist can be anyone who studies plants, animals, amphibians, reptiles, people. All of that is biology.
Yeah, thank you. That's a good answer. Okay, so I think we are kind of already touched on favorite. Let's see. Okay, so Jordan would like to know, did you ever feel like you wanted to give up? And if so, what kept you going?
I definitely have felt so overwhelmed multiple occasions. I think part of that also comes with like burning out, which is kind of a way to say like getting overworking yourself to a point of exhaustion. I think in science, we push ourselves really hard, just like to do our best. And we work really long hours and we study a lot to pass our classes that are very challenging. But I think for me, what kept me going was just kind of knowing that it was going to be worth it at the end goal. Like it was going to be delayed gratification, but that it would be rewarding to be able to be gathering new knowledge, and hopefully that knowledge was going to make a positive impact on my community and on society more broadly. So you kind of have to remember the bigger picture. And then you also have to, along with that, kind of learn how to take really good care of yourself so that you don't get to that point of wanting to quit, because really that's not healthy. But yeah, I don't know what other people want to chime in.
I would say this, in those times, would be a good time to fall back on your support system that you would have created, and they can help lift you up. So when you're feeling down, you'd go to those people. And so that's why you want to make those connections before that happens. And sometimes, you know, if something is like troubling you that much, or graduate school isn't for everyone. So there's a time and point when you have to think about what you want to do. There's still many ways you can do science. So yeah.
I wanted to say, for me, I would say learning how to think long term helps me with figuring out how to not give up on things. So, and like in terms of anything in life, like if you play a sport or if you play an instrument, sometimes you're practicing and you really do want to give up, but then you think, oh, far off a few months from now, I really wanted to like beat this other school. I really wanted to play this game. I really wanted to play in this concert. And so I think that keeps you motivated in the times when you feel like you want to give up. You start thinking about what your goal was in the long term.
I think that's a great point. I think all the panelists that spoke on that question are kind of touching upon similar ideas, which is when in doubt, because it's normal throughout our journey to encounter adversity and setbacks and to be down and to want to give up. That's normal. But it's important in those moments to remember why we're doing what we're doing and who we're doing it for. And I think that as long as you can remember your why when things get hard, it's a lot easier to persevere through, because you know that your end goal is bigger than your current situation. So the next question from our audience is, so I guess this is a little bit more relevant to them. They want to know, what are the best suggestions for colleges? And so for my panelists, I'm going to tweak the question a little bit. Why did you choose the college that you chose? And then how did it help you get to where you're at now?
HBCUs all the way, or Hispanic serving institutions or Native serving institutions, all of those. Go to places that are really invested in your personal development. I went to Hampton University. I will be honest and say for financial reasons, like HBCUs do give, in my experience, like better scholarships, better financial packages. And that was just really the icing on the cake, because when I got there, I realized all of these professors look like me or from another underrepresented background, and they really know how to talk to me. They care about me. And so I'm an advocate for HBCUs.
Yeah.
I was just gonna say, playing sports opened the door for me to go to college. I played soccer at the varsity level at Johns Hopkins, and so like I would have never imagined myself going to a school like Johns Hopkins, but you know, playing sports opened that door.
I can chime in as well. So I'm not sure if everyone knows what an HBCU is, historically Black college and universities. Just wanted to define that for the younger folks. And I kind of wanted to touch on a question I see in the chat about if we had straight A's in high school and straight A's in college. Ooh, that's funny. So I went to Georgia Tech for undergrad in Atlanta, and my mom actually went there for grad school. So I was looking for a school that had D1. So I ran track in college my first year, and I wanted to be somewhere where I would like the city. So Atlanta is a very Black city. I knew I would, you know, have a good time, but also be challenged. And that did not work out in my favor. School's rough. I did not have anything close to an A or B average. I had a C. I graduated with a C average in college. So that actually made it really challenging for me to get into grad school, because most applicants have at least a B average, if not an A average or higher. So I actually spent a lot of time doing, I would say, extra work to show that I was capable of, you know, getting into grad school and performing well. So once I got into grad school, I maintained an A average, but prior to that, no. But choosing college came down to, where would I get the best education, but also be in a space where I could enjoy my life and be in a space where I would be happy. So it's merging that, like, you know, what makes me happy and what do I like studying. And then I knew there would be a lot of resources for me, since I did know in college I wanted to go to grad school and was interested in doing research. So I knew my school had a really good science program, had a lot of opportunities to do research, even though I didn't do research, which anyway. But yeah, that was the thinking along choosing my school.
So I appreciate your input on that question, Chia Maka. And I think that one common theme that you'll kind of expect from people who get PhDs is that they're very high achieving, straight A students, because obviously if they're still in school years later, like they must love it and be really good at it. But believe it or not, making straight A's and passing all your exams and doing really well in school is not necessarily a prerequisite for getting a PhD. That's only a small part of what we do as scientists. Because again, we're doing research, so we're at the edge of knowledge. So as far as learning that information, retaining it, and being able to pass an exam, you do have to be able to do that sufficiently in order to get to the research aspect of a PhD. But from there, you know, we're not reading books, we're not taking exams, we're not like filling in the blank or answering a multiple choice question. We're in the lab doing experiments, asking questions, being resilient, perseverance is very important. And so there are a number of skills beyond just what grades you make on an exam that will determine your success as a scientist. And that's only one small part of it. So for anybody out there who is not a straight A student right now, that's okay. that does not in any way deter you from becoming a scientist? So I appreciate you for that question as well, Kiara. But go ahead, Kiara.
Oh yeah. So I would say my addendum to that would be to always try your best. Yes. So that would be like my addendum. This isn't us saying, oh no, you can go and shirk your no. Try your very best. And then also in addition to that, have like the research experience as well. I would say in order to create new knowledge, we have to kind of have a mastery of the current knowledge as is. And so even if you're not getting like that A, but you still understand the information and can kind of maneuver with that, then that's okay. So that's kind of like the realm that we're talking about. But like at like say like the lower levels, like high school and undergrad, yes, you want to get as high as you can, because then in graduate school, when like where the knowledge ends and where like kind of creativity starts is kind of blurred, and that's when grades matter a little bit less. But for like this stage where you guys are at, hit them books.
Thank you for that important addendum. Okay, so we're running out of time. I just wanted to ask all of our panelists individually to answer one last question, which is, what is one final piece of advice that you would give to our audience about careers in science?
I can start. I'm going to echo what my first research advisor told me. And she said, as long as you stay true to yourself, good things will continue to come your way. So I think, thinking about and reflecting on what makes you happy, what do you enjoy doing, and pursuing that and not giving up. So I would say, kind of being honest about that, but also getting help and sharing that joy with other people. Just talking to people, who are around you in your communities and saying like, I want to be a scientist, or I'm interested in this, or I'm interested in that, because the more you talk about it, the more you share your authentic self with the world, I think the more you attract people to come into your space and help you achieve what it is that you want, despite the obstacles and the challenges that may come your way. As long as you know, like, this is what I want to do, at least for now. That can change, or this is what makes me happy. Pursuing that, will always be fruitful.
I can go next. I guess one piece of advice that hasn't been given really is to like apply to that program or apply to that internship, even if you think it's out of reach. Some of us haven't been in families that have gone into academia, like gone to like prestigious schools or whatever school you may want to go to, whether it's tribal college, HBCU, or anything like that. Like, you can apply to it and there's a chance you'll get in. So don't like feel scared about that. So yeah.
I guess my advice would be, maybe not everybody tuning in today is interested in being a scientist, and that's fine, because, not everybody likes to think analytically about the world and has, all these scientific questions. But I think it's really important to be really passionate and to pursue, what you are interested in with a lot of conviction and purpose. I think that will bring you a lot of happiness, even if your career isn't in science. So I really recommend you to reflect upon what is exciting and interesting to you, to kind of pursue what that is.
I think Chia Maka and Sarah and Marilyn have really just hit everything. I would add to Sarah's point, don't sell yourself short. Someone asked in the chat earlier, and I tried to answer, but I think I might have deleted it. Like, what can you do at the elementary level, and maybe the middle school, high school level? I would say, like the other panelists said, really do reflect on what you enjoy, but also use the internet. Look at YouTube videos about things that you like. Find programs in your area that will help you. Find professors in your area or high school teachers in your area who run programs, or so really just continue to be curious. Think about the things that you like and never stop asking questions about those things.
Definitely early exposure to new things, to different ways of thinking. Yeah, and then just like honing in on the fundamentals. I think that's the best thing at elementary school age is like, okay, like is there like a program, accelerated math program to get you, say, finishing high school with above grade level math and above grade level science and AP reading, this higher level, as high level, like how early on that you can start getting ahead is just chef's kiss. Like you literally do yourself a favor. Like I know for me, I took summer classes in high school, and not because I was behind, because I was trying to get ahead, because I knew in college that it was, if I didn't if I didn't start early-ish, then it was really going to bite me in the keister. So if you can start early and maybe take summer courses, then I would do that as soon as possible.
I would like to add an addendum to that they can be fun things too. So like, for example, at Hopkins before COVID, biophysics department hosted a fun and science camp for 3rd and 4th graders. So if you can find things like that where you just are exploring, that will help you get ahead.
And give you something to write in your personal statement for graduate school too.
Yeah. So I think that one common theme that all of our panelists touched upon is that it's never too early to get involved. It's never too early to decide on what you want to do, or to at least start exploring options. And I think that's really the purpose of this event. And events like this, and a lot of what Black Girls Code is trying to do, is really expose you guys to different career options, so that when you get to, you know, our age and you go on to college, you choose what you want to study, and eventually you're prepared to make the most impact in the world that you can, and to be successful as well. So one sentiment that I just want to echo again is like, it's never too early to start. And you can start right where you're at. If you're in elementary school, if you're in middle school, if you're in high school, there are programs available that can get you into a lab doing scientific research, if that's what you're interested in. There are programs out there already that you guys can look into, as well as I think Jasmine had mentioned YouTube. There are a number of different resources out there that can really expose you to careers in science. And so finally, I just want to say that thank you so much for our audience for tuning in. Thank you for the organizers for planning this event. And most of all, thank you to the panelists who made it possible. This is the first installment of A Day in the Life of a Scientist. And I think it's been an extraordinary conversation full of information and wisdom. And hopefully it was beneficial to our audience, and you found it meaningful and encouraging. So as you're going about your everyday life, as you're going to school, and you're considering different potential career options, I hope that becoming a scientist one day is on that list. So make sure you guys stay tuned for future A Day in the Life of a Scientist events from Black Scientists Matter and from Black Girls Code, where the idea is really to expose students to potential careers in science by demystifying what a scientist is and demystifying what a scientist does. So again, thank you for the audience, thank you to our panelists, and thank you to our organizers, and I hope you guys have a wonderful evening.